All right, hello once again, Jeff Scott of Rankin Technical College. And what I've decided to do, as mentioned, is to go over some of the, I want to zoom out, I don't want to zoom in, so I guess that's it. Some of the major Git commands. So what we're going to look at right now is this right here. Got 15 minutes and want to learn Git. So we're going to go through all of this, and it's all using Git bash. In other words, it's from the command line. The major commands that we're going to look at are Git Init, which will set up a local Git repository for us. Git add, where we add one or more files. Okay. Git status, where we can check and see where we currently are. Git commit, and remember, commit will basically commit changes to our repository. Git push, where we push things out to a remote repository. Git pull, where we pull in things from a remote repository. And Git clone, where we basically make a copy of whatever it is we were working with. All right, so let's, without any further ado, as they say, let's go in and look at this. So it says 15 minutes, it'll probably be more, and I am going to do some reading, so sorry if this bores you. As it says, Git is a versioning system that allows one person or a group of people to work on the same documents, often code at the same time. It's a distributed version control system. That's the key thing right there. All right. Our terminal prompt is currently in a directory that they named Octobox. All right. To initialize, so I'm in Octobox. If I want to initiate or set up a Git repository, I come in here and I type in the command that you see right there. If you do click on it, I believe it'll take you to the information page that's out on their website. So I'm just going to type in here Git Init. Hit enter. And you'll notice it says initialized empty Git repository. What that does is, for lack of better words, and you're going to see it when I go through a more extensive example starting in the next video, but what it does is it's going to take, and wherever the folder is that you're creating your repository, it's going to create what looks like almost to be an invisible folder. It's not invisible, but it looks invisible because it starts with a period. That's called .git. All right? It's hidden, and it's where Git does its thing. So as it says, to save your progress as you go through the tutorial, head over and get a free Code School account. You can do that if you want. I don't need a badge. All right? So, Git status. So we just did a Git Init to set up our code repository, which added that .git folder. Now we're doing a Git status. Okay? And it says on branch master. Hopefully you remember this from the first presentation, that you're always working in a branch in Git, and the main branch is called master. All right, so previously we had nothing in there, but once we did the Git Init, we now have something in there. There are some files that get created for us. All right, so it says we should run the Git status command again to see how it's changed. So you can see what it looks like here. All right, it says nothing to commit, but I'm going to type in again Git status. And it says nothing added to commit, but untracked files are present. We've got this file that was created for us, octocat.txt. All right. If we want to take that file and actually commit it, we have to use the add command before we can do the commit. So git add octocat.txt. And it says here, it looks like our Git repository is working properly. Notice how it says git autocat.txt is untracked. That means that it's a file that has been created that we've done nothing with after creation. So to Git, it's a brand new file. So by putting this git add, we are telling Git, as mentioned here, to start tracking our changes that we make to this file. We're adding it to our code repository by using the git add. And once we do that and we hit enter, so it's giving us a list of everything we've done, but now once we've added that, it says, nice job, you've added octocat.git to the staging area. what that means is it hasn't been permanently put into our repository yet, but we're staging it, which says it's something that we're desiring to put into our repository. The reason you stage first is you might decide you can stage many files at the same time, and you'll see that later. And when you're doing that, you might decide, oh, I didn't want to stage some of these files. So you can add them and remove them before you actually commit them. All right? So it says, let's run the git status again. So you saw what happened when we ran it before. This is what it said. Okay? But now we've added that file that previously was not staged. So when I type in git status we want again, I believe. Yep. So when we type in git status again, now notice what it says. We have a new file in our repository. That new file is octocat.txt. Don't worry about what the file is. Literally, that means nothing. So it says, notice how Git says changes to be committed. The files listed here are in the staging area. They are not yet in our repository. We could add or remove files from the stage before. So in other words, the idea when you're working with those is that you can, if you decide, oh, I didn't want to put this there, or I did want to put this there, you can do so. If you want to store your stage changes, you have to run the commit command. Now, this thing in the double quotes is a comment that you add with it. So git commit -m, git commit -m. If we did it now and just hit enter, we wouldn't have any comment in there. And it's always considered to be a good idea to go and add comments as you're doing this. Whoops. Well, I guess they put part of it in there for me. So let me get rid of that. So now I've got git commit -m, add cute AutoCAD story. Hit enter. Now notice our master has been changed. We have added a file to our master, and we also have the comment that goes with it. That comment, for lack of better words, is more a README file. All right. The author says, it says, great, you can also use wildcards if you want to add many files of the same type. So if I wanted to add every text file, I could say git add star.txt in the single quotes. So it says I put some in a directory named octofamily, and some others ended up in the root. Luckily, we can add everything with just this git add. Excuse me. So let's do that right now. So git add star.txt. Just so you know, too, there also, I believe if you just say git add period, it'll add every file that you have staged. I believe it does. All right. And later we will talk about how to do this without doing it from the command line. You might even question me right now and say, why are you actually doing this from the command line? Many people who use Git don't use a GUI. They do it from the command line. All right. So that said, basically I added it. So all of these files that are in here now have been added to my repository. So it says now, when I say that, I should say they've all been staged to be put there. Now I want to add this. Now I'm committing them, so I am physically adding them to my code repository. So it's a git commit -m with, again, a comment. Add all the octocat txt files. I hit enter, and you'll notice now it lets me know all 4 of those were added. And it also lets me know where these live. I've got 2 files that live basically on the root of where I'm working, blue octocat.txt and red octocat.txt. 2 other ones that are in a folder called octofamily. All right, so if I look down here, it's showing me. And you'll notice, okay, I can at any time I can come in here and look at what I've got in here. All right, so the author says, so we made a few commits. Now let's browse them to see what we've changed. Well, I just did kind of show you that. But it says, fortunately for us, there's Git Log. It's a journal that remembers all of the changes we've committed thus far in the order we've committed them. So let's run the Git Log command and see what happens. And it tells me. Now, what we'll get into in just a bit in the next lesson when we go through this is we will go through there and we will put in our own name and email address. So we won't have trygit@github.com. Mine will say Jeff Scott, jpscott@rankin.edu, for example. And notice it also gives you dates. All right, I'm not sure where they got those dates from, but we'll see when we work on it in just a bit. So, great job. We've gone ahead and created the new repository. The author says they've created it for you. Okay. It says now try to push our local repo to the GitHub server, we'll need to add a remote repository. So that's what we're going to do in just a minute. This command takes a remote name and a remote repository URL, which is going to be right here. So they want us to run this command right there. So git remote add origin https://github.com/try-git/try_git.git. Now, hopefully I didn't make any typing mistakes. If I did, I'm sure they'll let me know. Just says success. So, next we want to do a push, and it says the push command tells Git where to put our commits when we're ready. Now we're ready. So let's push our local changes to our origin repo. That's the one that was created for us out on GitHub. The name of our remote is origin, and the default local branch, all right, what we're working on by default is master. The -u tells Git to remember the parameters so that the next time we can simply run git push and it'll know where to push, what to push, and where to push it to. So we want to git push -u origin master. And it says branch master set up to track remote branch master from origin. So it says let's pretend some time has passed. We've invited other people to our GitHub project. They have also made some of their own changes, so they pulled from the master that's out on GitHub, made their own changes, and pushed them back. So the author says if we want to check for the changes they've made, we can run, again, git pull. So previously we ran a push where we put our stuff out there. Now we're running a pull to grab what other people could conceivably have made. So if you look at these two commands, this we were pushing things to a remote server. Here we're grabbing things from a remote server. All right. And it says the author has come in here now, added a yellow octocat text file. All right, so the author put something in there for us. It says, looks like there have been some additions and changes to the octocat family, what I just showed you. All right, let's take a look at what is different from our last commit by using the Git Diff command. In this case, we want the diff to be our most recent commit. That's that head that we talked about previously. So we want to git diff head. And notice this stuff is all in lowercase unless you're showing something here like with head that's in uppercase. All right? So it's saying we've got, this is new. All right? So the author says another great use for diff is looking at the changes within files that have already been staged. Remember, a staged file is a file that, or files, that you have told Git that you're ready to commit, but you have not yet committed. So the author says here, let's use git add to stage octofamily-octodog.txt, which was just added to the family for us. So we want to git add octofamily octodog.txt. All right. So we've added it. Now go ahead and run git diff with the -- staged option to see the changes that you've just staged. So this will show whatever we have put into our staging area before we commit it. So it says you should see the octodog.txt was created. So let's look. Git diff -- staged. All right. And that's what it shows us. So it says, so now that Octodog is part of the family, Octocat is already pressed. Okay, this is a little goofy, but since we love Octocat more than Octodog, we'll turn this frown around by removing the Octodog. So in other words, we want to unstage a file. All right, so staging it is putting it in and getting it ready to commit. Unstaging is taking a file or files that are in the staging area and saying we don't want to commit those. So taking them out of our list of files to commit. So git reset octo family octodog.txt. Says success. So git reset did a great job of unstaging the octodog.txt, but you'll notice it's still there. It's just not staged anymore. It would be great if we could go back to how things were before the Octodog came around. Files can be changed back to how they were at the last commit by using the Git Checkout command. Git Checkout -- space and then whatever the target is. So the author says go ahead and get rid of all the changes since your last commit by running this command. So we want to run Git Checkout -- octocat.txt. So I'm saying grab the, check it out and basically remove everything that we put in since the last commit. All right. When developers are working on a feature or bug, they'll often have to create a copy, known as a branch, of their code to make separate commits to it. Again, this is one of the good things about using a product like Git, a versioning control, is that you're able to go in and have multiple people work on it at the same time. All right. We want to remove all those pesky AutoCADs. So let's create a branch called cleanup where we'll do all the work. So git branch cleanup. I think that's what it was. Well, I'm just going to take for granted that that's correct. All right. We're coming towards the end of this, so. Great. Now, if you type git branch, you'll see you have two local branches. The main one called master, which we've been using previous to this, and the new branch that's called cleanup. You can switch branches at any time by using the git checkout branch. So if we want to go from master to cleanup, we type in git checkout cleanup. So git checkout cleanup. All right, it says switch to branch cleanup. All right. Okay, so we're in the cleanup branch. You can finally remove all the octocats by using the git rm command, which will not only remove the actual files from disk, but also stage the removal of the files for us. You're going to want to use a wildcard here to tell it in one sweep to remove every single file that we have here that ends with .txt. So it's git rm star.txt. Git rm star.txt. And it says success. And you'll notice all our files have been removed. And what we had in here, not in there, but in the Octo family, those have been removed as well. So it told us to go through and everywhere that we had a file with a .txt on the end, remove it. All right, it says committing branch changes. Now you've removed them, you need to commit your changes. Feel free to run git status to check the changes you're about to commit. So let's do a git status and then the git commit -m with remove all the cats. So first we'll do a git status, and that's showing us what's been deleted. All right, notice did not use git commit. So it's saying basically those have been set up, but we haven't committed those changes. So we want a git commit -m, and then the comment was remove, was it remove or removed? I don't remember. Remove all the cats. All right, now it's telling us it physically deleted those 5 files from disk. All right, great. You're almost finished with the fix. You just need to switch back to the master so you can copy or merge your changes from the cleanup back into the master. So Git Checkout master means that we want to go back from where we were working, which was our cleanup, back to the master. So we want Git Checkout master. All right, and it's telling us that worked. The moment has come when we have to merge your changes from the cleanup back into the master. We're already on the master, so we just need to tell Git to merge the cleanup branch into it. So it's Git merge, then the name of the branch, which was cleanup. So Git merge cleanup. Git merge cleanup. And it's telling us now it is doing the permanent deletion for us on here. All right?
So if I can get keys with
Yep.
right here.
Okay.
Sorry about that.
All right. So it says you've just accomplished your first successful bug fix and merge. All that's left to do is to clean up after yourself. We now no longer need the cleanup branch. So we can use the git branch -d with the name of the branch to physically delete it. So git branch -d cleanup. Git branch -d clean up. Let's double check and make sure that's the right command. Git branch -d cleanup. It looks good to me. All right, now it says that that branch was physically deleted. So we're at the last step. All that's left for us to do is to push everything we've been working on to the remote repository, and then we're done. So we need to do a git push command. All right, and it says that's successful. Okay, so it says now you now have a little taste of the greatness of Git. It says you can take a look at the wrap-up page for more information. So if you do go there, okay, it'll tell you. So if you want to go through this, you can. It's kind of interesting. Notice continue learning Git. It says if you've enjoyed the course, your next step is to do this. I believe to continue learning, you need to pay. This first one was free, but I believe if I click there, it says try it for free. I don't know. But we just went through, I believe, the introduction. So there's a lot more in here. All right. So start the course now. I don't know if this is the one we just did. No, I guess not. So you can take a look at that if you have any interest in doing so. I'll probably do it myself. All right. So what I'm going to do next, I've now gone through and went through the SlideShare presentation. I very quickly showed you the article on how to use the terminal basics. I showed you the Traversy Git tutorial, which in the next lecture I'm going to mimic or mock most of it. I showed you where the Derek Bana stuff was. I'm not going to go through that. I'm not going to go through this, but I did go through the official site and the stuff that's there. So what I plan on doing next is to go through and kind of parrot what Brad Traversy did in his Git tutorial. And I'll do this as a series of, I don't know, 20 or 30 different steps. And I'm going to try to do them slowly so that we can see what's going on. And I'll try to provide at least a little bit of commentary at each step so we can see what's going on. I'll be back with that shortly.